Good morning, everyone. Welcome to Jerome Studyla YouTube channel. Today, we will continue with hydroxy compound part 2, focusing on the preparations of alcohol, reactions of alcohol, and a few related topics. Without further ado, let's get started. Preparation of alcohol, fermentation of carbohydrate, fermentation of sugar by yeast to form ethanol. This is the chemical reactions where we have glucose to produce ethanol and carbon dioxide. Next, we look into the hydration of alkene based on Markovitch rules. It says that when HX, hydrogen halide, is added to an alkene, the hydrogen atom attaches to the carbon of the double bond that already has more hydrogen atoms. And general mechanism is acid catalyzed hydration of alkene, where alkenes plus H2O, or example H3O, which hydronium ion, which involve based on protonation of water, where water molecule gain proton H and to produce alcohol. And let's look into the mechanism steps in general. Protonations of the double bond is where electron attack the hydrogen plus to form a carbocation intermediate. Next is a nucleophilic attack by water, which is to form an ozonium ion. And then we have deprotonation, which give alcohol. And then this is the general hydration mechanism for all alkenes, which is acid catalyzed. And then propane follow the same mechanism, but because it is unsymmetrical, you observe Markovitch selectivity, where the type of carbocation form when it depends on the primary, secondary, and tertiary, depends on the structure of the alkene. So based on the Markovitch rules, when HX, hydrogen halide, is added to an alkene, the hydrogen atom attaches to the carbon of the double bond that already has more hydrogen atoms. Preparation of alcohol in terms of the hydrolysis of haloalkanes. What is hydrolysis of haloalkane? Hydrolysis of haloalkanes, Alky Halides, involve replacing the hydrogen atom in the compound with the hydroxy group OH to form an alcohol ROH, and this is a nucleophilic substitution reaction. Typically, it carried out in aqua or alcoholic solution of a strong base like NO, OH or QOH. For the general reactions, we have RX plus OH to produce ROH plus X, where R is referred to alkyl group, example CH3, CH2, CH3, and X is referred to the halogen, is either chlorine, bromine, and I, and also OH negative is referred to hydroxide ion, for example from NaOH or QOH, and ROH is referred to alcohol. And example reactions, we have CH3Cl plus NaOH in a form of aqua to produce CH3OH plus NaCl. Example reaction, based on the explanation for the above example reaction is CH3Cl is a methyl chloride, which is haloalkane, and NaOH in a form of aqua provides OH negative ions in water. The hydroxide ion attack the carbon atom, bonded to the halogen, chlorine, replacing it and forming methanol, which is CH3OH. And the NaCl is formed as a byproduct. So mechanism is, there are two possible mechanisms depending on the structure of the haloalkane. One is SN1 mechanism, which is unimolecular nucleophilic substitution, which is a very common for tertiary haloalkanes, and it proceeds in two steps, as below, which is formation of carbocation by loss of the halide ion, which is slow step, and the second is the attack by OH on the carbocation to form the alcohol. And step number 2 is SM2 mechanism, which is referred to biomolecular nucleophilic substitution, which is a very common for primary and secondary haloalkanes, and it proceeds in one step below, which is OH negative directly attack the carbon bearing the halogen, displacing the halide ion in a single step. Then next, we move on to the preparation of alcohol. Preparation of alcohol, addition of Grignard reagents to carbonic compound. First, we have to look into the Grignard reagent and general reaction step, where Grignard reagents are organ magnesium compound of the form of R is referred to alkyl or RB groups, and X is referred to the halogen, usually Br, Cr, or L. And Grignard reagents are highly reactive nucleophiles and react readily with the carbonic compounds like aldehyde and ketones to form alcohol after hydrolysis. So general steps reaction, we can look into the general reaction step, secondary alcohol, and tertiary alcohol. First, we refer to nucleophilic addition, where Grignard reagent attack the electrophilic carbon of the carbonic group, C equals to O. Then step 2, hydrolysis. Acidic hydrolysis, usually H3O positive, as I mentioned just now, is hydronium ion, where it's involved in the process of protonation of water, where water molecule gain proton, H positive, then it becomes H3O positive, which is convert the intermediate into an alcohol. Then we have the RMX MgX plus C equals to O with the influence of ether, immediate it becomes alkoxide, which is H3O plus alcohol. And preparation of primary, secondary, and tertiary alcohol. For the primary alcohol, is involved carbonic compound, which is formaldehyde, HCCO, and Grignard reagent. And when this is involved in the process of reactions where the end product is a primary alcohol. Example, CH3 MgBr plus H3HO is produced ethanol at the end of the product. For the secondary alcohol, we have carbonic compound, aldehyde, except formaldehyde, where we have Grignard reaction. So, for this product secondary alcohol, at the end of the product is propane-2-OL is formed. And for the tertiary alcohol, carbonic compound, we have ketone and acetone, and also we have the Grignard reagent, and at the end of the product is a terbutanol is formed. And then next, we look into the alcohol reaction. For the alcohol as an acid, alcohol very weakly ionized in water, very poor acid, but with highly reactive metals like sodium, they can lose a proton to form alkoxide, RO negative, and release hydrogen gas. And this reaction is often used to prepare dry alkoxide, which are useful strong bases in organic synthesis. Then we have alcohol acting as a base. Alcohol contains a lone pair of electrons on the oxygen atom, which allow them to act as Lewis bases by accepting a proton, H positive, from an acid. Example reaction, we have CH3, CH2OH plus HA, then to form CH3, CH2, OH2 plus E negative. So in this reaction, ethanol, CH3, CH2OH is referred to the process, the example reaction just now, which uses its lone pair on oxygen to accept a proton to form the acid HA. And this form a protonate alcohol and the conjugate base of an acid A minus, and the structure of the protonated alcohol has an extra hydrogen attached to the oxygen. And this is the end product CH3CH2O plus H2, or it more clearly to say that CH3CH2 dash O positive. And then let's look into the alcohol reaction, where it involves three processes here. Is esterification, which is for step number 1 and number 2. And then we look into the dehydrations, which is where alcohol can be converted into certain product through the process of dehydration, elimination, or so-called substitution. And then finally, we have alcohol reactions in the process of formation of haloalkane. The first one is esterification, when the alcohol reacts with carboxylic acid to form ester in the process called esterification. And this reaction is reversible and typically carried out under reflux with a concentrated mineral acid such as H2SO4 or HCl acting as a catalyst. General reaction we have here is carboxylic acid plus alcohol, and with the ester, and then it will produce ethyl acetate, and it produce water. And then we have the dehydrations, where alcohol reaction dehydration, elimination and substitution, where alcohol can be converted into alkene through acid catalyst dehydration, and H2S4 acts as both an acid and dehydrating agent, which is heating the mixture drive of water, pushing the equilibrium towards alkene formation. So example in this case, during the process of substitution, from propanol, it becomes propane and water, or the other way around, propane and water is produced propanol. So next we have the alcohol reactions with formation of haloalkane. During the process of haloalkanes, where ROH react with HX to form RX, and the reaction rates are in the order where we have HI is greater than HBr. In this case, it's hydrogen bromide, and hydrogen bromide is greater than hydrogen chloride, and to form RX, or it says that HF is non-reactive. Reactivity of alcohol, we have several stages where we have tertiary, secondary, primary, and phenol. And for the general reactions in the process of formation of haloalkane, we have ROH plus with HX plus with to produce RX and H2O. So in this case, ROH is referred to the alcohol, HX is referred to hydrogen halide like HCl, HBr, or HI, and RX is referred to haloalkane or alky halide, and H2O is water. So it's actually when the process of formation of haloalkane, it involves several mechanisms. So in this case, I would say it's that through the tertiary alcohol, where SN mechanism, where OH is prototonate, become a better leaving group of H2O, and carbocations form, and then halide ion, where X negative attack the carbocation. And also we have here is a process of primary alcohol, where it go through SN2 mechanism, where protonated OH leave, halide ion attack, at the same time no carbocation. So how does it work is like when the OH group, based on the nucleophilic substitution reaction, when the OH group in alcohol is replaced by the halogen atom X from HX. And water is formed as byproduct, as I already mentioned, when CH3 CH2OH plus HBr to form CH3 CH2Br plus H2O. So ethanol reacts with HBr and bromethane is formed. So in terms of the reactivity of the alcohol, which we have the tertiary alcohol react faster than secondary alcohol and followed by primary alcohol and phenol. And why this reactivity of alcohol is happen? Because the tertiary carbocation formed during reactions are more stable than secondary or primary. And phenol is the least reactivity because the OH bond is stronger and the oxygen is stabilized by the resonance, making it less likely to react. And this is the process of formation of haloalkane. With that being said, thank you very much. That will end for today's presentation, and we will see you in the next presentations. So wish you all the best in your examination and study. And please don't forget to subscribe to Jom Study Learn YouTube channel. Thank you very much.